Let's take a look at some additional notes for this section. Let's take a look at this equation. We have y minus k, the quantity squared, over a squared, minus x minus h, the quantity squared, over b squared, equals 1. You're going to notice that the y term comes first in this equation, which means that your y-axis is going to be your transverse axis. This hyperbola is going to be opening up-down. HK is going to represent your center, so make sure you're getting your h value from this x term. Remember, that's the x component to your center, and the k value will come from here in the y term. A is still going to represent your distance from the center to one of the vertices. C is still going to be the distance from the center to your foci. And you're still going to be using the equation c squared equals a squared plus b squared. Remember that you're going to need to add these two terms together and then take the square root to get your c value. And when we're working with hyperbola that open up down, our equations for our asymptotes are going to be y equals plus or minus a over b times x. Let's go ahead and take a look at this example. We have negative x squared plus 4y squared minus 2x minus 16y plus 11 equals 0. And we want to go ahead and put this in standard form for our hyperbola. Now, when you're looking at your squared terms, our x squared term here and our y squared term, you want to try to figure out which one of those terms might come first. Keep in mind your equations for the hyperbolas have a subtraction sign between the two fractions. So if I notice that this x squared term has a negative sign in front of it, then when I go to rearrange all my terms here, I'm going to go ahead and pull all my y terms out first, and then I'm going to do my x terms so that that minus sign can appear in the appropriate spot in my equation. You'll see that I gathered all my y terms together and I left a blank because I'm going to have to complete the square in this problem. I gathered my x terms together and the same thing, I left a blank so that I could go ahead and complete the square. I subtracted my 11 from both sides to give me negative 11 on that right hand side, and I went ahead and left two blanks so that whatever numbers I put here on this side, I can make sure I add them to the right hand side as well. Now also notice that in front of our y squared term we have a 4, so I'm going to go ahead and factor out the 4. Now that we have the 4 factored out, we've got y squared minus 4y inside our set of parentheses here. I also still have that blank. Let's go ahead and complete the square on this one. I'm going to be looking at this term in the middle, which is the 4. I'm going to be dividing it by 2 and then squaring it so I can fill in my blank. Let's go ahead and work with our x terms next. Remember that we have that minus sign there, so I'm going to go ahead and pull the negative sign out. And now we can go ahead and work with our middle term here. We have a 2. We want to go ahead and complete the square, so let's divide it by 2 and then square it to fill in that blank. Now keep in mind we also have to put these numbers onto the far right hand side of our equal sign. Be really careful in this case. Even though I have a positive 4 right here, remember that you factored out this 4. So when you want to fill in this other blank, what you really added here was 4 times 4, or 16. So I'm going to need a positive 16 on one of those blanks on that right-hand side. And the same type of thing is going to happen here for this one. Remember that you factored out that negative sign. So a negative 1 times a positive 1 is going to give me a negative 1, and that's what I need to add to that last blank. And now remember that the whole point of doing that was that we created perfect squares, so we can go ahead and factor. If we're working with these y terms, this trinomial is going to factor into y minus 2 times y minus 2. Don't forget to bring your 4 down. Let's go ahead and do the x terms next. This is going to factor into x plus 1 times x plus 1. And if we simplify the stuff that we have on the far right-hand side of the equal sign, we're going to get a positive 4. So we can rewrite our equation as 4 times the quantity y minus 2 squared minus the quantity x plus 1 squared equals 4. Now remember that your formula for a hyperbola has a 1 on this side of your equal sign, so we want to go ahead and divide each of these terms by 4. So for our equation, we're going to get y minus 2, the quantity squared, over a 1. Technically you don't have to write that 1, but since we need something in the denominator, I'm going to go ahead and leave it there so that we have it to work with. Minus x plus 1, the quantity squared, over 4, equals 1. Now that we have our equation, let's go ahead and pull off our center. Remember that you're taking your h value from the x coordinates. So my h value here is going to be a negative 1, and my k value will be a 2. So my center is going to be at the point negative 1, 2. Keep in mind that your y term comes first, which means you're going to have some type of vertical transverse axis. It's not going to be the y-axis because you're not centered at the origin, but it will be a vertical transverse axis, and our hyperbola is going to be opening up-down. Our a value is 1, so we're going to have a distance of 1 unit from the center out to one of our vertices. Keep in mind your center is the point negative 1, 2, and to get to one of your vertices, you're going to be counting up and down 1 unit to get to those vertices. And to get your distance, the c value from the center out to the foci, you're going to be using the equation a squared plus b squared equals c squared. And we're going to end up with a distance of radical 5 units. Remember again that you're counting from the center of your hyperbola. And our b value is going to be 2. We're going to need that so that we can find our asymptotes. Remember that our formula here is y equals plus or minus a over b times x. So if we plug in our a and b values, we're going to get 2 equations here, y equals 1/2 x and y equals negative 1/2 x. Again, remember that when you go to graph those, you are graphing those from your center, not from the origin. Let's go ahead and take a look at our graph. The first point we want to plot is our center. Our center is the point negative 1, 2. The next thing I want to plot are my asymptotes. That's going to kind of help me with my graph. Remember that we had 2 asymptotes, y equals 1/2 x and y equals negative 1/2 x. When we go to draw these, remember also that you need to draw them from the center point on your graph. Now when I go to plot the equation y equals 1/2 x, I'm counting up 1 unit and over 2 from my center. Keep in mind on my scale, I'm using 2 blocks to represent 1 unit, so be careful depending upon what scale you use on your graph. I connected my dots with a dashed line, and I labeled mine with the equation y equals 1/2 x. Let me go ahead and do the other asymptote of y equals negative 1/2 x. Let's go ahead and put our vertices on our graph. Remember that your a value was 1, so I'm counting up and down 1 unit from my center. Again, keep in mind I'm using 2 blocks to represent 1 unit, so when I count up 1 unit, my first vertex is going to be at the point negative 1, 3. And if I come down 1 unit from my center, my other vertex is going to be at the point negative 1, 1. And now I'm going to go plot my foci. Remember that your c value was radical 5. So from my center, My x value here is not going to change. It's going to stay a -1 for both of my foci. And then my y values, it started here at a +2 for my center, so I need to go up radical 5 units, so 2 plus radical 5. And then I also need to come down radical 5 units, so 2 minus radical 5. And then once you have those 2 points plotted, you can go ahead and draw your hyperbola. Remember that it needs to connect to your vertice, and it's going to sit inside your asymptotes. So here's a sketch of what my final graph would look like.